Alright, so we cannot do mathematics without talking about fractions. And unfortunately, I think most people don't like fractions. And they're going to pop up in statistics a lot. So I'm going to give you the statistical context in which they come from. Is if I have so many things that I can choose from. Okay. And we'll say there's 8 things I can choose from. But the thing I'm measuring, there's only 2 of them. And so in statistics, we'll talk about the frequency being 2, but the relative frequency being 2 over the 8 total things I have. And the thing to think about is this fraction bar works like a division. It's saying I'm taking 2 things and I'm dividing it 8 times. And if we do that, there's a couple different ways we can write it. The easiest, and the one that we want to know, easiest is a relative term, isn't it? The quickest is to reduce the fraction. Now I tend to look for reducing fractions. I notice this is divisible by 2 and this is divisible by 2, so I could rewrite the top as 1 times 2, and I could rewrite the bottom as 2 times 4. And whenever you have the same thing in the top and the bottom, that's like the fraction, let's say 1 over 4, right, because there's the 1 and the 4, and that 2 over 2 I'll put together. Well, 2 over 2 is 1. And so this reduces to 1 over 4. Or I can divide it on the calculator, and 4 goes into 1, well it goes 0 times, but it goes into 10, 2, and we get 0.25, right? So how did we do that? We turned it into a long division problem, because a fraction bar is just like a division. And I put my decimal place next to my 1 and I go, hey look, 4 can't go into 1 evenly. And so I borrow a 0 from here. I'll line up my decimal point here. And 4 goes into 10 twice. 2 times 4 is 8. I subtract and I'll bring down another 0 because I have loads of zeros I can borrow from over here. And 4 goes into 25 times. 5 times 4 is 20. And there's no remainder, so I don't have to borrow anymore. All of these are useful ways of looking at numbers. I tend to use the fraction and the decimal. And the calculator will help us move back and forth between the two. But one of the things we have to work on is figuring out how to reduce these fractions. Let's look at another one where the top is bigger than the bottom. So I have 24 times 15. And so if I look at the top of this, I have 8 times 3, 4 times 6. There's multiple ways I can look at it. Now, I want to look for numbers that multiply into 24 and 15 that are the same. So I can work my way through my times tables. I can try to figure out, what multiples go back. I've seen these enough. I kind of know the number I'm looking for. Or I can write what's called a prime factorization. So I'm going to look at the bottom, and 15 is only multiplied by 3 times 5. These numbers don't have any other multiples, and then we call these prime numbers. I'm going to do upstairs now, and I'm just going to start with 2. 2 times 12 is 24. Well, I know 12 is 2 times 6. So I'm going to write 2 times 2 times 6. All right, 2 times 2 times 6. 4, 24, yes, same thing. And then I know 6 is 2 times 3. So 2 times 2 times 2 times 3. And so what I'm doing is I'm prime factorizing this. I'm getting only prime numbers. And when we tend to write prime factorizations, If you watch the little video on order of operations, when I multiply the same thing multiple times, I say that's 2 to the power of 3. Just save space, saying I'm multiplying that. And 3 times 5. Well, here I have 3 over 3, which is 1. Right, we'll rewrite this as 3 over 3 times 2/3 over 5. Or, and again, I'll reverse 2/3. That's 8 over 5. And so that's all the weird math going around, but it's not really the process we use. It's just kind of everything that we can look at, especially when we're hunting for these things to cancel. Sometimes listing all of these things can help them cancel. Now what you get used to seeing is you go, well, is this divisible by 2? Yes. Is the bottom divisible by 2? No. So that's not the number I'm looking at. Is this divisible by 3? Yes. Is the bottom divisible by 3? Yes, it is. So I'll do the divisible by 3. 3 times 8 over 3 times 5. Those over top of each other gives me 8/5. And this is how we tend to do it. But what's lying underneath the background is all of these prime factors, and we try to grab all the factors that are the same. Sometimes I get lost, and so the prime factors are my way back out. And so that's called reducing a fraction. We always want to get the fraction in its reduced form. Because there's certain fractional patterns, like 1/4 is equal to 0.25, 1/5 is equal to 0.2. There's certain reduced forms that if we have them, so I have 8/5, well that's 8 of these, or 1.6. It gets easy to convert if I know this is in its simpler form. Well, there are things we can do with fractions mathematically, and it's funny, fractions multiply and divide a little bit easier than they add and subtract. I'll look a little bit more at adding and subtracting in a separate video. But if I have a half, and I'm going to multiply it by 3/8. What's nice about multiplication with a fraction is the tops multiply the tops, and the bottoms multiply the bottoms. So 1 times 3 is 3, and 2 times 8 is 16. And so 1/2 of 3/8 is 3/16, if we convert these back to words. Right? This is half of, because we can sometimes use of for multiplication. And so when multiplying a fraction, any fraction, you multiply the tops and you multiply the bottoms. Now sometimes they can simplify. So let's see, if I have 2/5 times 3/16. I can look at this and go, well, when I'm all said and done, I'm going to have my 2 times 3 over top of my 5 times 16. But 16 and 2 are both divisible by 2. So I can turn that into 1 times 3 over 5 times 8, or 3/40. Where you do your simplification with multiplication doesn't matter. I try to do it first so I don't get such big numbers coming out of it. Alright, and earlier, if you had watched on order of operations, I say division is related to multiplication. So if I take 3/4 and I divide it by 1/4, division is the same as multiplying by the reciprocal. So I take 3/4 and I'm going to multiply it by this number flipped over, 4 over 1. That's what we mean by reciprocal. We take the fraction and flip it over. And so the 4 over the 4 cancel, and I get 3. Let's look at another one. I could do 3/2 divided by 4. So I'm going to turn it to multiplying over the reciprocal. So 3/2 times, well, 4 I could write as 4 over 1. So it's reciprocal when I flip it over as 1/4. And this becomes 3/8. And so fractions are something we're going to see often. More often than not, we're going to turn them into a decimal and speak about it in percentages. which I'll talk about more as we go on. We want to get comfortable reducing them so we can kind of hold them in our pocket and have an idea of their value as we use them.